Question 1. A plane surface of area 200 cm square is kept in a uniform electric field of intensity 200 Newton per centimeter. If the angle between the normal and the surface and the field is 60 degree, the electric flux through the surface is A 0.5 Newton meter square by C, B 4.5 Newton meter square by C, C 2 Newton meter square by C, D 3 Newton meter square by C. So now over here we have to find electric flux, that is 5, and we have the formula E S cos 5. So we already know that we have been given the values 200 and 200, that is 200 into 200. But since this is in centimeters, we convert it into meters as 10 raised to minus 4 into cos 5. So we use cos 60, that is half. So when you solve this, you get answer as 2 Newton meter square by C. Option C is the correct option. An electron experiences a force equal to its weight when placed at a point in an electric field. What is the intensity of the electric field at that point? We have mass given as, mass of an electron is given as 9 into 10 raised to minus 31 kg, and of course the charge of an electron is 1.6 into 10 raised to minus 9 kg, minus 9 coulombs. So A is 10 into 10 raised to minus 8, B is 5.5 into 10 raised to minus 11, C is 15 into 10 raised to 11, and D is 2 into 10 raised to minus 11. So now we know F is equals to mg, and we also know that F is equals to QE. Force is equals to mg and force is equals to QE. So from 1 and 2, from these both, we can say that mg is equals to QE. Over here we have to find E. Therefore, E will be mg by Q. Over here we have been given the values of all these. G is 9.8, M is given to us as 9 into 10 raised to minus 31, and Q, that is the charge, is given to us as this, it is 10 raised to minus 19. So this will be 9 into 10 raised to minus 31 into G, that is 9.8 upon 1.6 into 10 raised to minus 19. So when we solve this, we get it as 5.5 into 10 raised to minus 11. Option B is the correct option. Question 3. In a region where electric field intensity is 5 Newton per coulomb, 50 electric lines of force are crossing per square meter, where field intensity is 20 Newton per coulomb, will be A 50, B 100, C 200, D 150. We know that the number of lines of force is directly proportional to the field intensity E. Therefore, N2 by N1 will be equal to E2 by E1. We have to find N2, that is number of lines passing. So by this formula, we will find N2 as E2 by E1. This N1 will go up into N1. So this is E2 into N1 by E1. Substituting the values, we have 50 into N1, that is 20, upon E1, that is 5. So when you solve this, you get 200. Option C is the correct option.
Electrostatics. Question. Gauss theorem states that the total normal electric induction over a closed surface in an electric field is equal to. So as we know, according to Gauss theorem, the total normal electric induction, that is TNEI, over any closed surface with any number of electric charges situated at the position inside it. It is equal to algebraic sum. It is equal to algebraic sum of all the charges, or I can say algebraic sum of charges enclosed by the surface. That is summation of Qi is equal to Q, where the summation ranges from I is equal to 1 to I is equal to n. So option C, that is summation of Qn, is the correct answer.
Question 5. The potential of a spherical conductor of radius 5 cm is 10 volt. What is the potential at the center of the sphere? A 2 volt, B 10 volt, C 0, D 50 volt. So over here there is a spherical conductor and we have to find the electric potential. Let's take 2 points. Point A, which is there at the center of the sphere, we have to find this point, and point B, which is there on the sphere, for which they have given us 10 volts. The radius is 5. Over here it is 10 volts. So what the electric potential will be on the sphere, the same will be inside the conductor. Therefore, if B is 10 volts, even A will be 10 volts, because A has to be equal to B. 2 points are there in the same sphere, whether inside the sphere or on the sphere, the electric potential is same. Therefore, option B is the correct option, 10 volt. Unit of electric flux is A Newton meter per coulomb, B voltmeter, C coulomb per Newton meter, D volt per meter. So over here we have to find the flux, electric flux. We know the formula of electric flux is EA. Okay, now this E is V by D and A is length into length. So this length gets cancelled. So we have A and D, which we have designated for length. So V is volt and length is meter. Therefore voltmeter, option B is the correct option. Question 7. A charge of Q mu C is placed at the center of a cube of side 0.1. On the electric flux diverging from each face of the cube will be A Q into 10 raised to minus 6 upon epsilon naught voltmeter, B Q into 10 raised to minus 6 upon 6 epsilon naught voltmeter, C 6 Q into 10 raised to minus 6 upon epsilon naught voltmeter, D Q into 10 raised to minus 4 epsilon naught voltmeter. We have been given a cube in the question, and we know a cube will have 6 sides. And we are supposed to find out the flux or the charge. Electric flux is Q, that is charge into 10 raised to minus 6 upon N epsilon naught. This is the formula for electric flux, voltmeter. This N stands for number of sides. Over here we have been given a cube. Cube has 6 sides, so it will be Q into 10 raised to minus 6 upon 6 epsilon naught voltmeter. This matches with our option B. Option B is the correct option. 8. A dipole is kept in a hollow sphere of radius r. The total electric flux leaving the spherical surface is given by A phi is equals to Q upon K epsilon naught, B phi is equals to 2Q upon K epsilon naught, C phi is equals to 8 pi r squared Q upon epsilon naught, D 0. Over here we have to focus on this word dipole. Dipole is two opposite charges, positive charge and negative charge, plus Q minus Q. Positive, negative, both of them will cancel out each other. Once they cancel out each other, my net charge of a dipole will be 0, and since my charge is 0, my flux will also be 0, because phi is Q into 10 raised to minus 6 upon N epsilon naught. If my Q is 0, my Q is 0, then my entire flux will be 0. Hence phi will be 0. Option D is the correct option. The electric field intensity at a point near and outside the surface of a charged conductor of any shape is E1. The electric field intensity due to uniformly charged infinite thin plane sheet is E2. The relationship between E1 and E2 is A to E1 is E2, B E1 is equals to E2, C E1 is equals to 2E2, and D E1 is equals to 4E2. Now first E1 stands for electric field intensity at a point near and outside the surface of a charged conductor. So that will be sigma upon epsilon naught K. This is the formula. And the second electric field intensity E2 is due to a uniformly charged infinite thin plane sheet. So that formula is sigma upon 2 epsilon naught K. So from this we have E1 is equals to 2E2. E1 is twice of E2. Option C is the correct option. A metal plate of area 2 meter square is charged with 12 into 10 raised to minus 6 coulomb. The surface density of charge is A. 3 mu coulomb per meter square, B. 4 mu coulomb per meter square, C. 6 mu coulomb per meter square, D. 8 mu coulomb per meter square. Over here I have to find the surface density. Surface density formula is Q by A. Both of these are given to us. Q is given to us as 12 into 10 raised to minus 6 and A is given to us as 2. Both of them are given into proper units. We do not have to change the units. We will simply solve this and we get the answer as 6 into 10 raised to minus 6. Converting this into mu, we get 6 mu coulomb per meter square. Option C is the correct option. Metal plate of area 0.5 meter square is given a charge of 50 mu coulomb. What is the charge density? A. 10 raised to minus 3 coulomb per meter square, B. 2 into 10 raised to minus 3 coulomb per meter square, C. 10 raised to minus 4 coulomb per meter square, D. 2 into 10 raised to minus 4 coulomb per meter square. We know that the surface charge density, the charge density is Q by A. Again, both of these are given to us as 50. Q is given to us as 50 mu C and A is given to us as 0.5. Q is given to us in the form of mu, therefore we will have to multiply by 10 raised to minus 6. Therefore, we have 50 into 10 raised to minus 6 upon area which is given to us only in meter square. So, we will keep it as it is. Once you solve this, you get 10 raised to minus 4. 10 raised to minus 4 is option C. Option C is the correct option. Given a charge of 5 into 10 raised to minus 3 coulomb acquires a potential of 500 volt. The capacity of the conductor is A. 5 mu F, B. 10 mu F, C. 15 mu F, D. 20 mu F. We have to find capacity. The capacity formula is given to us as Q by V, where Q is given to us as 5 into 10 raised to minus 3 and V is given to us as 500. So this, we will solve this and after solving this we will get 10 mu F. 10 mu F is option B. Option B is the correct option. So of capacity 4, mu F is charged to a potential of 1000 volts. The energy, the condenser is A. 1 joule, B. 4 joule, C. 6 joule, D. 2 joule. We have to find the energy of the condenser, which is half into CV square, half into C. Capacity is given to us as 4 mu F. So 4 into half into 4 into 10 raised to minus 6 into V square. Volt is given to us as 1000. 1000 is 10 raised to 3. But over here you are having square, V square, that is 10 raised to 3 square. So that will be 10 raised to 6. This will get cancelled and we will have half into 4, which boils down to 2. Option B is the correct option. Question 14. A capacitor is used to store 24 watt-hour of energy in 1200 volt. What should be the capacitance of the capacitor? A. 120 mF, B. 120 mu F, C. 24 mu F, D. 24 mF. So over here we have been given energy, that is 24 watts, but then they have given in hours. We will convert it into seconds, so therefore that will be 24 into 60 into 60. We know that E is equals to half CV square, but E over here we already have as 24 into 60 into 60. Therefore 24 into 60 into 60 will be half CV square, that is half into C into V square. V is given to us as 1200, so 1200 into 1200. So when you solve this entire thing to find out C, you get it as C is equals to 24 into 2 upon 100, which is 12 into 10 raised to minus 2, 10 raised to minus 2F, that is 120 into 10 raised to minus 3 mF. Option A is the correct option. 15. Which one of the following is known as electrical energy tank? A. Resistor, B. Inductor, C. Capacitor, D. Transistor. So over here we have this capacitors which will store in the energy, whatever the current is passing through it will first store in all the current, and hence they are known as energy tank. These are also used for charging the devices. Hence C, capacitor is the correct answer.